Okay, welcome back to Lesson 3, math students. Okay, so guess what? Lesson 3 is basically a shortcut to Lesson 2. Although there are applications where you're still going to want to use long division, but there's a method called synthetic division where you're dividing a polynomial by a binomial, and you don't have to write so much. So here's an example of a long division scenario, and this would be the equivalent using synthetic division. First of all, a couple things to point out. Notice the 3, 0, negative 7, negative 9. 3, 0, negative 7, negative 9. Okay, you'll notice this is x minus 2. If we go x minus 2 equals 0 and then solve for x, look at that. That 2 is here. And then finally, you'll notice this are the coefficients of our quotient, and this number here is our remainder. Okay, so it's a way to get, and the process is very similar. So we're going to practice that on some examples on the next page, okay? All right, let's zoom in on this. Okay, example number 1, first of all. Okay, complete the following synthetic division to determine the quotient and remainder when 2x cubed minus 3x squared minus 8x plus 15. So just like with long division, we need to have a placeholder for each degree of x. 3, 2, 1, and then 0. So we have 2, negative 3, negative 8, and 15. You write the coefficients going across the top. You draw sort of an L, a big L, leave enough room to write numbers in right here below the coefficients we wrote down. And then take your x minus 1 that you're dividing by, set it equal to 0, solve for x, add 1 to both sides, x would equal 1. That's the number that goes here. Now by doing that, we can actually use the adding method of synthetic. So carry the 2 down, then we multiply 1 times 2, and that number goes here. Then we add these two numbers, negative 3 plus 2 is going to be negative 1. And then we repeat. So we go again, 1 times negative 1, that's going to be negative 1. Okay, and then again we add. Negative 8 plus negative 1 is going to be negative 9. Okay, do it again. 1 times negative 9 is going to be negative 9. Add, and we get 6. Okay, so our remainder should be 6. This is our remainder here. Okay, so writing it in this form they asked for, we'd have our original polynomial given in the question with the x's, divided by our divisor, which was x minus 1. This was our divisor here, should equal our quotient. Oh, we got to turn this back into x's. So if we started with x cubed and we divided by x, we should be ending up with x squared, and this too is our coefficient on that. Then descending order, so if that's x squared, this would be 1 less, so minus 1x, and then minus 9 is our constant. Okay, so there's our quotient, 2x squared minus x minus 9, plus our remainder, which was 6, that's this last number here we got, over our divisor, x minus 1. There we go, final answer. Okay, example number 2. Consider the polynomial, yada yada. Use synthetic division to find the quotient and remainder when yada yada is divided by x plus 2. Okay, let's set that up. Notice they give you like no room to do this. That's because it shouldn't take too much room. Okay, so x plus 2, first of all, set it to 0. So you know x is equal to negative 2, and that's what's going here. Okay, our coefficients. Okay, are we missing any terms? 5, 4, we're missing x cubed, so we're going to have to put a 0x cubed in there. Squared, 1, okay, so we're good. Now the coefficients go across, leave a little space between them, okay? And then 0 for x cubed, 3, negative 2, and finally 1. All right, so remember the process? Carry the 5 down, multiply negative 2 times 5, negative 10. Then we add to get negative 16. Multiply again. Okay, you guys keep going with that. Pause your video and let's see if we both get the same remainder, okay? Okay, so did you get a remainder? You probably thought you were doing it wrong because the numbers were getting so big. I did too. Okay, so remainder of negative 239. Ouch. Okay, and then that's part of their answer. They also want to know the quotient. So if we started with x to the fifth and we divided by x, we should end up with x to the 4. So the first coefficient is 5, and then the term is x to the 4. And then you just keep going down from there. Negative 16x cubed, 32x squared, negative 61x plus 120. And there we go. Then they want you to find the value of the polynomial when x is replaced with negative 2. Okay, so let's write this out. Let's call it p of x equals, and here's our polynomial, 5x to the fifth minus 6x to the 4. We don't have to write our 0x cubed, so plus 3x squared minus 2x plus 1. And they want to know when x is replaced with negative 2. So function notation, we'd go p at negative 2. And everywhere you see x, we're scooping it out and putting in negative 2. Okay. Whew. Negative 2 and then plus 1. Okay, go to your calculator. Let's put that in, see if we get some big number. Okay, so pause your video, go do that. Okay, what did you notice? We got a value of negative 239. Pretty weird number to get coincidentally again. So when we subbed in negative 2, now where'd that negative 2 come from? Did they just, oh, look at this. That's the same number. That's an easier way to find the remainder, isn't it? Okay, well so comment on your answers. The same. Okay, that's going to come up again in the next lesson, okay, that little concept there that we just did. Okay, let's look at example 3. A little bit of a teaser for the next lesson. How's that? Okay, example number 3. If x plus 3 is the divisor in the following synthetic division, calculate the values of m and p. Okay, so if x plus 3 is the divisor, let's set that to 0 to see what x would equal. Okay, so x equals negative 3. That's going to go there. Carry the 2 down. Let's follow this through. Negative 6, add, negative 4, multiply. Negative 3 times negative 4 is 12. Okay. And okay, so right there we've got a bit of an equation. We've got that negative m plus 12. I'm just going to write this off to the side. Negative m plus 12 looks like it's going to equal 2m. Well, guess what? We could actually solve for m. That's an equation. So add m to the other side so that you have 3m, and then divide by 3, and we find out that m is actually 4. So this is going to be 2 times m, which we know now is 4. So this will be 8 here. Okay, then we can continue on. Negative 3 times 8, negative 24. So guess what we just found out? N was negative 24. Then finally add 16 and negative 24 is going to be negative 8. So we found out M is that, N is negative 24, and P is negative 8. There we go. 3 answers just by following our synthetic division through, and had to use an equation at one point. All right, let's look at the next page. Okay, the next example. When 2 blah blah blah, notice we're missing a coefficient, is divided by x plus 2, the remainder is 3. Find the value of a. In the next lesson after this, we are going to learn how to deal with that in a better way. But for now, we'll do the synthetic division to figure this one out. So coefficients across the top, including the a. Okay, if x plus 2 is our divisor, that would mean in synthetic division we're going to put a negative 2 here. Okay, carry down. Okay, and I want you to follow this through. The only thing we do know is the remainder is 3. So we do know this number here at the very end is going to be a 3. See if you can figure out what a is going to be, okay? You should really pause your video now and then come back when you think you have a. Okay, let's see how far you got. So we went negative 2 times 2, negative 4, add those. Oh, I messed up here. Sorry, don't look at this. Okay, so add those, we get negative 8. Multiply again, so we would have negative 16. Okay, negative 2 times negative 8. Oh, positive 16, sorry. And then we would add those, but we don't know a. So let's just write it as a plus 16. Okay, then once again we multiply. So it'd be negative 2 times that. times a plus 16. And then we're stuck at the end, right? But we do know if we went 3 plus this term, negative 2 times a plus 16, we do know we should get a remainder of 3. So guess what? We could solve this now. Let's do that. So let's first of all subtract 3 from both sides. Okay, and then we would have negative 2. Let's multiply that through. Negative 2a. Actually, we don't need to multiply it through. We can leave it there. A plus 16 equals 0. Divide both sides by negative 2. 0 divided by negative 2, still 0. So we have a plus 16. I'll throw that extra step in. A plus 16, still 0 there. Subtract 16, and there we go. We know, therefore, that a would have to equal negative 16. Let's just work this back and see if that would actually work. So if this was negative 16, we add those, we would get 0. 0 times that, this would be 0. 3 plus 0, 3. There we go. Maybe you were able to figure that out without all the algebra, and if you were, good on you, okay? Now, this here, the last part, synthetic division with ax minus b. If you have a coefficient in front of x, synthetic division gets very complicated, okay? There's fractions, there's ugliness, okay? I would not bother. In that situation, synthetic division is not easier anymore, so why don't you just go back to long division, okay? So in other words, we're not doing this, okay? If you have to divide by a divisor that has a coefficient in front of x, a binomial, you do not want to do synthetic. Just go ahead and do long division, and then you'll have your answer. Okay, so that then, therefore, will end our lesson, because we're not going to do this last example with synthetic, and we don't need to do it with long division because we had enough examples before. So, good job. We're able to do now the assignments from lesson 2 and 3, and you'll be ready for class tomorrow. Thanks for paying attention. See you then.